Hey, welcome to FX021. This is part 2 of the Houdini Particle Project. So let's get started. So first thing you need to set the project. So we go File, New Project, and we just name our project to particle. And the project path, you can create a photo and copy the path. I'm gonna use this one, this path here, and just paste here. And these are the folders you're gonna create inside particle folder. So we don't need HDA, we don't need texture, I think we need. And we don't need desktop, audio, scripts, flipboard. I think that's all we need. So we just hit accept. And you can see it creates a particle folder, and that's all the folder it creates. And now the Houdini project is set, but the file is not saved. So we just hit Ctrl S and we just type particle. And you see the dollar job means the current path. So he automatically finds the path we set, and he will save the Houdini file inside the folder. So accept. You can see the particle heap is inside and it's saved. The first thing we want to do is create particles, like in the video I showed. This is the first step. So we want to create particle symmetrical like this. So first thing first, we need to create the source, like the emitter. So hit tab and type geo. So this is like a folder. Create geo, just name it source. And we can create sphere. And we can add a mountain node to add noise on top of that. But when you connect these and set your view flag on the mountain node, and you can see when you change the height or element size, there's nothing changed. Why? You can hit the button here, it means point. And when you mouse hover on the viewport, hit W, which is wireframe mode. And you can see there is only one point in the scene. Because this sphere is not a polygon, we need to change the type to polygon. So now it's a polygon. You can see there are more points to manipulate with. And we can add more frequency to it, maybe 30. And we can disable the point display. Yeah. And we can change the height maybe to 0.01. Let's try, 0.2. Okay. And we can play this. You can hit the play button here, and you can see nothing changed. The first thing you'll notice is it plays really fast. You can click the clock icon here, which it will allow Houdini to play like 24 frames per second, and now you can see it's grow much slower. And we can set the project to like around 72 frames total. So it's about 3 seconds. And yeah, so we want the noise to move, and you can see the slider here. When we change the slider, it's animating. So when you hover your mouse on the time here, it will pop up hint. It says use $T to make noise time dependent. So let's type $T. And now when you play, you can see the sphere is animating. And for now we can set our camera. Let's say the camera is here. Find the camera at the top and Control click. So Control click will set camera in your view, and yes, and click the camera icon to go to the perspective mode. Yes, and now we want to emit some particle from the sphere. So what we do, everything Houdini simulates are in the dot network. So you type dot network and you double click to go inside. You can see here it said dynamic, and when you go back to the geo level it said geometry. So this here are all the geometry, and you feed the source to the dot network, and then Houdini will calculate the particles and output the result. So we don't need to use the dot network here because inside there are only the output node. We can use the popnet, which will do the particle simulations. They are basically the same, just the pop network has more presets in it. So we just delete popnet and connect the mountain node to the first input, the popnet, and set your view flag on the pop network. And we can double click inside. So you see the dot network only has the output node, but the popnet, it has these presets. And you don't need this one, this is just merge. So these three nodes are the main thing you need to do a particle simulation, and it's in the dynamics context. So let's play this. And let's hit play. You can see the particles are there. But particles supposed to like fly away from the surface. Why it's not flying away? That's because we don't have velocity. So you can select the source first input node here and go to the attributes tab. You see here it said initial velocity, use inherited velocity, but we don't have velocity in this. In the source. The source is what we feed here is this sphere with the mountain node that doesn't have velocity. So we need to add some velocity to the sphere so that the particle will fly. There are multiple ways to add velocity. We can write some code, which is pretty simple. Use the attribute wrangle node. Attribute wrangle is where you can write your code, and you can also use the VOP network. Attribute VOP. Yes, these two are the same one, but this one allows you to write code, and this one is more like a visual coding. It's like a blueprints, but these two are the same thing. I will show you both. How to add velocity by code or by blueprints. So first thing we can call it set velocity. It's just the name of the node, and we can connect here and set the view flag here. And we can go to the first row. So how do we add the velocity? So in code, velocity is a vector, so we type v, add v. The first v means vector, and the second v means velocity. And equals, let's say 0, 1, 0. Because it's a vector, so there are 3 numbers, and we set the velocity 0, 1, 0 means with x, y, and z. So we set y to 1. Y is the up vector, so the velocity should be pointing up. We can visualize our velocity by hovering our mouse on the node and click the node info icon. And you can see here we got a velocity attribute. You can see when we hover our mouse to the mountain node, we don't have the velocity attribute, we only have a p attribute. And after we add this code, we have an attribute called velocity. And we can visualize our velocity by clicking on the velocity attribute here, and you can see it's all pointing up. If we change this to 100, they are pointing to the right, which is the X direction. So yes, let's change to up direction. And this is one way you wish you do in the code way. And you can also do the same thing with the attribute warp, which is blueprints in Unreal, kind of similar. So let's put our view flag on attribute warp node and go inside. Now you can see the velocity vector visualizer disappear because we don't have velocity on this here yet. So we're gonna set it. So double click go inside. You can see the velocity here, and we can use the parameter here. And we can call it whatever you want. You can call it velocity. I'm gonna call it vel. And the velocity is a vector. So we can find vector with vector here. And we just set default to 0, 1, 0 and just connect to the velocity here. And you can see it's the same. They are the same. So let's say we're gonna use a switch node here and connect both two to the switch node, and you can toggle left or right input. I go to the 0, 1, 0, 1. 0 means the first one and 1 means the second one. You can switch between both. Now you don't see a difference because they are all the same. Now that we have our velocity set, we can just put our view flag on the pop network where we do the particle simulation here. We can disable the visualize for the velocity. You can click node info and find the velocity attribute here and click on that to disable the visualization of it. And we can change the background to dark so that it's easier to see. We can hover our mouse on the viewport and hit D and go to the background and change the color thing to the light, from light to dark. And I will turn on the point display. And now you can see when we hit play, they all go up. It's because we set our velocity attribute to point to the up vector. But the problem here is they are like too uniform. We don't want it looks like too uniform. That's because all the velocity vector are 0, 1, 0. We want to add some noise to the velocity, which you can, let me delete this switch, which you can use a node called point velocity. I think this is a node of Houdini 18, so if you are using Houdini 17 or 16 or any version before that, I think you don't have this node, but I will show you how to create your own point velocity later. So let's connect the point velocity here and put our visualize view flag on the point velocity and turn on the velocity visualize again. Because we already have our velocity in here, it's 0 and 0. So we're gonna set the initialization to keep incoming. And with this incoming, we want to add some noise. So just toggle this, and you can see now the velocity is different. Not like before it's all 0, 1, 0. Now we add noise. It's different. So we can change the scale here. We can change the size. And we can change the tolerance. I think this is good. And if you are using Houdini 17 or any version before where you don't have point velocity node, you can create here in the attribute valve. I will show you how to do that. So double click into the attribute valve. We can add noise to the velocity, so we can create a noise. You can use the first one and fit the position to position and add these two. So the velocity and the noise, and feed our output to the velocity, and you can see it's changing. And we can just change our frequency here, and we can change our roughness, just like and we can promote this parameter, but I'm not gonna do. So all the controls are here. Roughness, yeah. So basically these two are the point velocity and this are the same. So if you are using Houdini 17 or the version before, which you don't have this point velocity node, you can do it in this way. So because I have point velocity, so I'm not gonna use this one. And I just create a switch node here in case I'm gonna use this one. So yeah. So now you can see if I change from 0 to 1, you can see it's different. So I'm gonna use the first one here, the point velocity, and just connect to the pop network here. And we'll put our view flag on popnet and go to the first frame. And just select popnet and now visualize the velocity, just clicking velocity attribute here. And now we can hit play. And now you can see it's more random. Yeah. But there are too many particles in the scene, which I don't like. So I can go inside the pop network. And let's make this window a little bit bigger. And we can see, select the source first input. And we go to the burst tab. And this one here, if this is set to 1, it will emit particles. We can turn off this to 0. So this means active, so it will emit particles. How much they're gonna emit? They're gonna emit 5,000 per second. So you can hover your mouse on this. You can see the number of particles to emit per second when constant activation is on. So I think it's too much. We can turn that to 10 or 20. Let's say 10. And we can go to the first frame to refresh. So when you see the timeline turns orange, means some value are changed in your scene. So the scene is gonna be different. So you can go to your first frame. And we can hide our guide geo and turn off the point display here. And I'm gonna hide my guide. And now you can see there are less points in the scene. And now you can see, yeah, that's more random and looks much better. And I don't want and now we go back to the geo level and we can see our sphere. I don't want have sphere under the ground, so I'm gonna delete this one. So the way I'm gonna do is use a click node. So let's put it here and put our view flag on the click node. You can see it click the sphere. And now let's see the pop network. And hit play. Yeah, much better. So it's all emitting from above the ground. And as you can see in my trailer, all the particles are symmetrical. So what we do is you can save your simulation, but this is pretty light. It's not a heavy simulation, so I'm not cache this simulation, but you can. So now I want to make it symmetrical. So we can delete half of this and then we mirror the another half to the right. So that's what I'm gonna do. So also we're gonna use the click node to delete half of the particles. So just copy and paste here and connect the result to the click node, and put our flag on the clip. And you can see nothing changed because the direction is wrong. So we are gonna change it. So you can see the Z direction is the left to right. So we can change the Z direction. We can change to the Y 001. So you can see the right half is deleted. You can see I will turn on the point display to see it. So before it's like this, and now it's like this. And we can also add a mirror after that, and you can see we also need to change the mirror direction, so it's the same 0, 0, 1. We can use the add node to connect, but before that we're gonna add some trails to the particle. So we can use a trail node and connect after the click node and visualize the trail. And now you can see there are a few increased trail lengths. You can see it's like a motion blur or kind of thing. You can also increase the trail increment. I will leave it like this, and you can use the add node to connect these points. Now these are points, not lines. We want to connect them, so you can use the add node here. We can go to the polygon group, and now we can set our view flag on the add, and we go to the connect by group. Now I can set the mode to all points. We don't want to set to all points. We want to connect by attribute. So we want to connect by the ID of each point. Because if this one ID is 0, we have a trail node. So these will have the same thing, same ID here. So we're gonna connect. See, now they have lines here. And now we're gonna mirror it. And we go to our camera view. And turn off the point display. And go to the first frame and play. I want to make sure we have the same camera, so same camera position, so you can copy my value here. So this is the translate and rotate value on my camera, and yeah, that's basically it. But you see the particle is still like the movement is still not very interesting. The lines are very straight. So we want to use the velocity field to influence the particles. I can show you an example video. So as you can see here, it's a campfire. So you can see these fire embers. They are affected by the fire. So they are not fire like randomly. They are like affected by how the fire moves, and it will influence these fire embers. That's exactly what I want to do on my particles. So I want to create a fire simulation, and I want to use a fire simulation's velocity field. I will take the velocity field and use that to drive my particles. So I'm not gonna use the velocity I create in here. I don't want to use this. I'm gonna use the velocity field from the fire simulation to influence my particles. So this is what I'm gonna talk in the next chapter.